Surprise! Yes, I am alive, as it says right here, but all of this was a complete lie. I actually did record this lesson like 3 times, and it was crap. I could not put that on the site because you guys would not like it, and then you'd stop coming back for good instead of just coming back probably to see if there's new stuff. So first thing I want to do is go ahead and delete this. So go ahead and there it goes. It's gone. It's deleted. No more. So now I have this old blog post, but that's okay because I will be updating that very soon after I get this lesson uploaded. So, what are we going to do today? First of all, I want to talk about something that's been going on. This is PHP Video Tutorials, the website that gave me the inspiration to start Java Video Tutorials. But Lee, the guy that runs this site, is shutting it down. He can't take the time to work on it anymore, and so he's my good friend and decided to pass it on to me. And so I'll be operating 2 sites, PHP Video Tutorials and Java Video Tutorials. But I'm also going to work on PHP VT in collaboration with Developer Monkey. So if you go back here, if you look down here, Learn Ajax from Ash, he has completely redone his site. It's really pretty awesome. He's got these nice JavaScript animations. But you could read about Ash over here. He's in the UK, and so we're going to collaborate on this new PHP Video Tutorial site. And so it's going to be PHP Video Tutorials partnered with Java Video Tutorials and Developer Monkey. So if you visit his site, Developer Monkey, he's working on a lot of cool stuff to revolutionize how programming is taught through videos like this. So I might embrace these new ideas with my videos, but you'll definitely see it if you choose to come over to PHP Video Tutorials. So in the next month or so, this URL will point to this page here, and hopefully we'll be able to get that underway. So PHP is a cool language. It'll be cool if you want to come and check it out. So the next thing, I don't know if you're a Microsoft fan or an Apple fan, or if you use something else, but maybe you know, maybe you don't. I had the opportunity to work at Microsoft over the summer, and I was working on Windows 8, super secret stuff. Well, at least it was all super secret until till the 13th of September 2011, when they announced all of their Windows 8 things. And so I can actually there we go, Windows 8, and probably the first well, the images aren't that great, they're probably old, but if you look at the news that you've been seeing, let's get a screenshot. There's a screenshot. This guy right here, that's basically what I worked on. It's the Newsreader sample app. If you go and download the preview release build of Windows 8, you can do that. You can do it from somewhere. Yeah, right here. You can go to this URL and download the Windows Developer Preview and play around with Windows 8 and play around with the News app, and that's something that I built. So, well, I built it with a couple of other interns on a team, but it was a lot of fun, and I hope you guys like it if you choose to check it out. So that was keeping me busy over the summer, and so we have Developer Monkey, and PHP video tutorials, and that's about all I have for now. Let's get on with the lesson. So my goal today is to talk about memory, not so much management, but how Java works with memory. So what do I mean by that? Well, right now we know that when we say int x equals 5, we know there's some variable called x and it holds the value 5 somehow, but we don't know how all that works. And I haven't really even told you or talked about what happens if I were to say int y equals x. What does that mean? Does that mean that y and x are the same variable? Does that mean that y just gets a copy of x? How does this all work? So the way we start this out is to go over, there's two types of memory. They're the same hardware, but there are two different places in RAM that Java will store values. There's the stack and there's the heap. So the heap is kind of this one big blob where just a bunch of data is stored, and the stack is an area where not only data is stored, but also information like which function you're currently in, or the return address, meaning when you jump out of a function, where does it go back, or what else would that's basically it, and that and then data. But what kind of data goes on the heap, what kind of data goes on the stack, so we're going to talk about that. So as you already know, Java has I think 8 primitive data types. They are int, long, double, float, boolean, char or char, and byte, and short, and that is all 8. And when I say a primitive data type, I mean anytime you create a variable, like anytime you create one of these variables, it stores the value of that variable directly in a memory location. Okay, so how is that different from some object data type? So object data types are anything else that usually starts with a capital letter. But whenever you use the new keyword to create something, that's an object variable. Other ways you can have it's an object data type. Other ways you can have objects are strings. Java automatically makes everything in double quotes to be a string, and that's an object. Sometimes you have integer or other primitive data types that are wrapped into object types. So you can have like integer x equals 5, and so this is a big, well, it's not a big integer, it's just a big I integer. And the 5 is obviously not an object, it's just a 5. But what Java does is it says, well, I need an integer, I see a 5, so it knows to auto box that. So that's the same thing as saying new integer 5, right? And so what does all this mean? So in Java, well, in programming languages in general, there's usually a notion of pass by value and pass by reference. And maybe you've heard of these terms before. There's a huge misconception in Java that this is wrong, and I'm going to say that it's wrong because I want you to know that it's wrong instead of just learning that it's wrong inductively. So in Java, there is a misconception that says primitive data types are passed by value and object data types are passed by reference. That is wrong. Everything in Java, without exception, is passed by a value. What does that mean? So I'm going to show you a simple example starting using this my method function, which is really a method. And let's give it a parameter. Let's say it takes an int called x, and all it does is print out that x. So if we say my method and we give it a 3, obviously when I compile and run this program, it's going to print out 3. So what happened here? The 3 got passed by value into this as an argument to this method. And so what does that mean? The value of 3 gets copied over here into this variable, and I print out that copy. So since it's a copy, and I were to say x equals 5, now what happens? Let's create a new variable. Say int let's call it x again, equals 3, and now I can change this 3 to an x, and I'm going to print out x now. System out println x, and so I have a 3 here. X is 3. I call my method on x. Well, like I said, x gets passed by value, so a copy of x goes over here. So this x is a 3, and now I just change that x to a 5, and I come back out. But since this x was passed as a copy, it's still 3 over here. Only the copy got changed. So if I print out x, it still says 3. So just to prove it to you, there we go, 3. So that's what pass by value means. And people who might be familiar with Java or taking a course at university might think I'm blowing smoke here because they think that object data types are not passed by value, but I promise they are. Let's do a quick example here, and instead of saying int x, let's make integer x, and just to be consistent or whatever, I will use the constructor. Yeah. And so I have an object here, and this no longer takes an int, but it takes an integer. And so we're good. I'm passing this. But now let's say x equals new integer 5, right? So what's going to happen? Well, like I said, pass by value. Well, there's a little bit more going on in this example. It still prints out 3, but what exactly is going on? So the way objects work in Java is, like I said, your primitive types are stored on the stack. Object types are stored on the heap. But all of your variables are stored on the stack. What does that mean? This variable is a pointer to an object type called integer. So this variable doesn't directly contain an integer type. All it contains is a memory address for another memory location that contains some integer. So when I say this x is on the stack, all that's really on the stack is this memory address. That memory address is an address on the heap. So if I say integer x equals new integer 3, this statement here creates a new integer on the heap. And this is not on the stack. But its memory location, its memory address, is put right in this variable x. So when I say my method x, what am I giving? I'm giving it the variable x. What is x? X is the address that points to some integer on the heap. So down here in my method, this takes integer x. Well, we know variables in Java can't point to objects. They can't contain objects, sorry. They can't contain objects. They can either contain a primitive data type or a memory address to some object data type. Now, Java takes care of all that for us. And so anytime it's expecting an object, it knows it's really going to be just a pointer to an object, and the programmer doesn't even know about it. So when I say integer x, So what's happening? The address of this new integer 3 is being passed by value into this my method. So the address of this integer here is right here. And so this x here is still pointing to this integer here. But what happens now when I say new integer 5? I'm saying create a new integer on the heap and take the memory address of that new integer and put it in x. So what have I done? I've created a new integer and I put the memory address in x. But I haven't done anything to this integer. And because I passed by value, I didn't pass by reference, I passed by value. Basically, I made a copy of that memory location or that memory address and put it over here in this x. This x points to that new integer object, which is a 5. But this x is still pointing to this x and this x. Well, forget about this x. This x and this x is still pointing to this object. All we did was make a new object here and assign it to this x, which is a copy of this x. So that's why when I print it out, like I just did, I still get the 3. Now, the same goes with strings. We can make this a string. And I will say, hello world. That is such a, let's change it to yo earth bitches. Now this takes a string. And let's do something else. Let's say h equals h dot substring 0 to 2, right? So basically the substring method, all it does is take a portion of a string and return it. So it's going to start at the 0 position and end at the 2. So 0, 1, 2, and so that means it'll return that portion. So what am I doing here? Well, I'm creating a string on the heap. That's what this does. I'm storing the address of that string in x. X lives on the stack. I'm calling my method on x, which is cool because my method is expecting a string. I copy that address over here to h. I say h is this expression here. What does this do? Well, you might have heard this before. Strings in Java and in most programming languages are what it's called immutable. You cannot change a string once it's created. So, since we know that fact, we know that this cannot change the value of that string. So when I say h.substring 0, 2, it actually builds a new string for me. And the new string that it builds is this yo. And it builds that string on the heap, and it takes the address on the heap and puts it in h. Where's h? H is on the stack. So when I do this, compile that and run it, what's it going to print out? Well, we said h is pointing to this new string, but remember h was just a copy of x, so x hasn't changed. Of course. Okay, now let's take this one step further. Like I said, strings are immutable. What does that mean? They can't be changed. Once they're created, that's that. Not every object in Java is immutable. Many of them are mutable. One that you know about is a simple array. So int array, and we're going to create a little array, and we'll just say it's 2, 3, and 4. And that is our int array. Well, it turns out int arrays, or all arrays in Java, are mutable. So let's make this method take an int array, and we'll call it a. Now what's happening? This expression here builds a new array on the heap, and it takes the address of that array and stores it in X. X is where? X is on the stack. So X, we know it's a variable, it's on the stack. It contains a memory address that points to some int array that lives on the heap. So if we call my method X, we take this memory address and we make a copy of it and put it over here in this variable called A. And so A it's perfectly legal because A is it's a memory location, memory address, and it points to an int array which lives on the heap. How do we know that? Because it's a direct copy of X, and X satisfied that as well. So if we say so A is that address, but we can say something like A of 0 equals 1. And so this, what does this do? This says go to A, which is our variable, which is the memory location of this int array. But Java knows that since it's really an int array on the heap that we're trying to get at, it goes to the int array on the heap, and it uses the special array notation with the square brackets, and we can access the 0th element or the first element and assign it the value of 1. So this A is still pointing to this same array, and all we're doing is we're changing the value of that guy. And so we're changing it to a 1. And so I know we can't print out an array like this, but it's pretty easy to let's just print out one at a time, right? So we'll say X of 0 and X of 1 and X of 2, right? So this should print out, if we did not run my method, it would print out a 2, 3, and a 4. But what we did, we passed the reference, we copied it over to A, although they're still pointing to the same object, the same int array. We're changing the 0th element in that int array to a 1, and then nothing's happening, but it was changed. It was mutated. We couldn't do that to a string because it's immutable. And then we printed out 0, 1, and 2. So what happens? Like I said, 1, 3, 4, it got changed, and so this 2 is no longer a 2, it's a 1. And there we go. So I hope you understand now what I mean when I said when I say everything is passed by value. Variable, this little X guy, he either points, he either contains, let's say variables are all on the stack, right? And they all either contain a primitive data type, which is int, short, float, double, long, boolean, chair, car, whatever, one of those, or some memory address. And the memory address is always a location on the heap. So I'll quickly do another example. Let's you know what? No, I won't, because I don't know if it's necessary at this point. So yeah, just watch this lesson again and drive that point home, because if you ever hear somebody say that objects in Java are passed by reference, you will be able to correct them. University professors say that objects in Java are passed by reference, and it's completely wrong. Java doesn't even have passing by reference. Some languages do, like C and C++ and C# and PHP and many languages, but in Java, no. It's all passed by value. Now, whether that value is primitive or it's just some location of another object, you know, that could make a difference. But But remember, immutable objects cannot be changed. And so if you pass an immutable object to another method, well, you know that it'll be the exact same object that you're holding on to when you get out of that method. Now, if it's mutable, you don't know that for a fact, like I just did here. So hopefully that made some sense to you guys, and I really think this lesson went well, and maybe I can do another one pretty soon. So it's good to see you guys, and I'll definitely be back later.